Hi, I was just kidding about that being the end of membrane transport. I forgot one thing. That's called vesicular and bulk transport. So all the transporters that we talked about before moved pretty small things. The biggest was a molecule of glucose. But sometimes the cell needs to move things that are rather large, like whole proteins that are being secreted. Or in the case of some white blood cells, they actually bring in a whole bacterium and kill it and digest it. So the cell has to have some way to move things that are really too big or too numerous. There are just so many that it wouldn't make sense to use a channel or a transporter. So for this, cells use vesicles. But they have to have a way to move things using these vesicles without causing the membrane to rupture. So let's take an example, and let's say that this is a vesicle that contains proteins that the cell is secreting. All right, so it's got lots of proteins in it, and those proteins are way too big to use a transporter. So the cell puts these proteins in a vesicle. They're actually already in a vesicle from traveling from the endoplasmic reticulum to the Golgi, but now they're in a vesicle, and that vesicle moves so that it is right up next to the plasma membrane. Okay, so here's our vesicle now. Right. And once the vesicle docks at the plasma membrane, the membrane separates so that the vesicular membrane and the plasma membrane become one, and there's now an opening that allows the proteins to go outside of the cell without ever having created a break or an opening in the plasma membrane that could cause damage. Now this process is known as exocytosis. Right? Exo for exit, moving it to the outside of the cell. The same thing happens, however, if a cell needs to bring something in. So let's say that we have outside of the cell some kind of bacterium. Right? The cell, in order to take it in, will do exactly the opposite of this. First, it will make a little pocket, right? You have to ignore my drawing because I just broke the cell. But it creates a little pocket like this. And forms that pocket around the bacterium. And then the membrane pinches off. And as a result, we now have the bacterium inside the cell, where it can go merge with a lysosome and be broken down. This is called endocytosis. Endo because it's coming in to the cell. Now, endocytosis has two major subcategories. One, which I just demonstrated, is called phagocytosis. This phage means to eat. So the cell is taking a big bite of whatever is on the outside, and that is phagocytosis. So that is for large things. You will, when you get to Bio-24 and you're learning about the immune system, you'll learn about phagocytes and things like macrophages, macrophage, big eater, cells that specialize in doing this in order to keep our cellular environment clean and pathogen free. Now, sometimes cells do what's called penocytosis. Peno means to drink. And in that case, the cell is just doing the same thing that it did with phagocytosis, But instead of there being a bacterium, it's just picking up whatever happens to be outside of the cell. It's sort of like rummaging through the junkyard looking for things that might be useful to the cell. So cells will take a sip of the external fluid and bring it inside and look to see if there are things that the cell can use for its cellular functions. All right, so we have exocytosis, which is using vesicles to get rid of things, and endocytosis, which is using vesicles to bring things in. Both allow for the movement of either large or numerous particles without causing any damage to the plasma membrane. Now that's it.